Every major technology revolution runs on a hidden layer of machinery that most people never see. Behind the apps, the chatbots, and the headlines about artificial intelligence sits a physical foundation of silicon, servers, and raw computing power. And one company now sits at the center of almost all of it. This is the story of how NVIDIA, a business that started by making video games look better, quietly became the engine of the AI revolution, and one of the most valuable companies on Earth. To understand why that matters, you have to understand a simple truth about this moment in technology. The AI revolution is not only about software. It is not only about ChatGPT or the tools that write, code, and generate images. Underneath every one of those systems is hardware. Specialized chips running inside enormous data centers, performing trillions of calculations every second. Artificial intelligence is, at its core, a machine that turns electricity and computing power into something that behaves like intelligence. And NVIDIA builds the machines that make that possible. Around the middle of 2026, NVIDIA's market value was above $4.5 trillion, placing it at the top of the global public company rankings. But that position was never obvious. For most of its history, almost no one saw it coming. NVIDIA was founded in 1993 by Jensen Huang and two fellow engineers, Chris Malachowski and Curtis Preem. The idea, reportedly sketched out over coffee at a roadside diner in California, was straightforward. Build better graphics for personal computers, especially for video games. Through the late 1990s and 2000s, that is exactly what the company did. It became known for the graphics cards that gamers wanted, chips that could render fast, detailed, three-dimensional worlds on screen. In 1999, NVIDIA released a product it called the GeForce 256 and described it with a new term, the GPU, or Graphics Processing Unit. That name would eventually come to mean far more than the company itself realized. So what actually is a GPU, and why does it matter for artificial intelligence? Think about the main chip in most computers, the CPU, or Central Processing Unit. A CPU is like a small team of extremely capable workers. Each one is fast and flexible and can handle complicated tasks. But there are only a few of them, and they mostly work through problems one step at a time. A GPU is built on a different idea. Instead of a few powerful workers, it has thousands of smaller ones, all working at the same time. Individually, each is simple. Together, they can perform an enormous number of calculations at once. For drawing graphics, this is perfect, because every pixel on a screen can be worked out in parallel. This approach is called parallel processing, and it turned out to be useful for far more than games. By the mid-2000s, researchers began to notice something. The same kind of math that draws a video game, huge grids of numbers multiplied together over and over, also describes many problems in science and engineering. Weather models, physics simulations, financial calculations. All of them could run faster on a GPU than on a traditional processor. So NVIDIA made a decision that looked strange at the time. In 2006, it released a software platform called CUDA. CUDA allowed programmers to use NVIDIA's graphics chips for general computing, not just games. For years, this was an expensive bet with an unclear payoff. NVIDIA spent heavily building tools and support for a market that barely existed. Many outside the company questioned why a gaming business was pouring money into scientific computing. But Jensen Huang kept investing. He believed that demand for massive parallel computing would eventually arrive. That demand arrived through artificial intelligence. Modern AI is built on neural networks, systems loosely inspired by the human brain that learn patterns from data. Training one of these networks means performing an almost unimaginable number of simple calculations. The system adjusts billions of internal values again and again until it improves. It is exactly the kind of repetitive, parallel math that GPUs were designed to handle. The turning point came in 2012. A group of researchers entered a major image recognition competition using a neural network trained on NVIDIA gaming GPUs. Their system, later known as AlexNet, did not just win. It won by a wide margin. And it signaled that deep learning, powered by GPUs, was about to reshape the entire field. From that moment, the long gamble on CUDA and parallel computing began to pay off. Over the following decade, artificial intelligence moved from research labs into the center of the global economy. And NVIDIA moved with it. When companies wanted to build large AI models, they needed thousands of powerful GPUs working together. When cloud providers like Amazon, Microsoft, and Google built out their data centers for AI, they filled them with NVIDIA hardware. When a new wave of AI companies emerged to train systems like large language models, they turned to NVIDIA for the computing power to do it. The company's chips, from its earlier data center processors to its current Blackwell and Rubin platforms, became the default tools for building advanced AI. Just as important, CUDA had become deeply woven into how AI software is written. Years of code, libraries, and expertise had grown up around NVIDIA's platform. That made it difficult for customers to switch to a competitor, even when alternatives existed. The business results were remarkable. Demand for AI chips outpaced supply. NVIDIA's revenue climbed to levels the company had never seen. And the growth was driven overwhelmingly by data centers rather than gaming. By 2026, NVIDIA was widely reported to hold around 80% of the data center AI accelerator market. Its market value had climbed above $4.5 trillion. This is where the story becomes bigger than one business. The world is now spending enormous sums building AI infrastructure. That means data centers, power supply, networking, cooling systems, and the chips needed to run artificial intelligence. Many people now describe this as one of the largest infrastructure build-outs in modern history, and NVIDIA sits at a crucial point within it. When an industry races to build something new, the companies that supply the essential tools often capture an outsized share of the value. NVIDIA became one of those suppliers, not by making the final product, but by making the equipment almost everyone else needs. Behind this sits Jensen Huang, who has led NVIDIA since he co-founded it more than 30 years ago. His central idea, repeated for years before it became fashionable, was that traditional computing was reaching its limits. He believed the future belonged to what he called accelerated computing. That means using specialized chips to handle the heaviest workloads. For a long time, this sounded like a niche argument. Today, it describes the direction of the entire industry. NVIDIA's strategy has shifted with it. The company no longer sells only chips. It now designs complete systems, processors, networking, software, full data center platforms. In other words, NVIDIA is no longer just selling parts. It is selling the blueprint for an AI factory. But no position like this is guaranteed to last. NVIDIA faces real pressure. Rival chip makers are building their own AI processors and working hard to close the gap. Some of NVIDIA's largest customers, the same cloud giants that buy its hardware, are designing custom chips of their own. They want to reduce how much they depend on NVIDIA. There are also supply chain limits. The most advanced chips rely on a small number of manufacturers, concentrated largely in Taiwan. There is geopolitics. Governments have restricted the export of advanced AI chips, particularly to China. That cuts off part of NVIDIA's market and pulls the company into tensions between the United States and China. There is also the possibility that AI itself changes. As AI shifts from training huge models to running them cheaply at scale, different kinds of chips may become more attractive. And there is the simple reality that the technology industry moves in cycles. Companies that look unstoppable can be challenged by a new approach that no one saw coming. Which is, after all, exactly how NVIDIA itself rose. Still, the deeper lesson of NVIDIA's rise is not really about one company or one stock price. It is about where value collects during a technological revolution. The most visible products tend to get the attention, but the businesses that build the underlying infrastructure, the roads, the power, the engines, often end up holding the most durable power. NVIDIA did not predict ChatGPT. It did not invent the AI applications now spreading across the world. What it did was spend 2 decades building the computing engine those applications would eventually need. Then it placed itself at the center of the moment when demand finally exploded. Whether it holds that position for years or is one day overtaken, it has already revealed something important about the future economy. In the age of artificial intelligence, whoever builds the engine helps decide how far and how fast everyone else can go. But NVIDIA is only one layer of the AI revolution. In the next video, we will look at the companies trying to build the intelligence layer itself, OpenAI and Anthropic. If this breakdown gave you a clearer view of how the future is being built, subscribe to Future Wealth Lab, where we explore how money, power, AI, and business are shaping the economy of tomorrow.